Quiet on the set, please. This is number 3. And we're given the following energy data below. I'm writing out the reaction. Okay, and the free energy data is delta G naught formation, and it's in kilojoules per mole. Is minus 396.46 minus 237.18 minus 237.18, and that's not a typo, and minus 369.31. Okay. And A. I ask you to find delta G naught for the equilibrium process. What is that equilibrium process, by the way? But it's acetic acid. It's acetic acid in water. So it's just the dissociation of acetic acid in water. And now what I was also saying, I had some responses. Delta G is always, delta anything is always final minus initial. Now this is a case where I'm really going to be sensitive to detail. In other words, it's very important that you include the details. There's enough space on the paper, and so what you start out with is, I'm starting out with the final product. Even though if you look ahead, you'll notice that this product, the hydronium ion, the free energy of formation of the hydronium ion is the same as the free energy of formation of the water. So it's going to drop out of the actual calculation, but don't shortcut this at all. You can take that part out when you go do the calculation, but for right now, we want to show everything involved. And so delta G naught is equal to, there is 1 mole of hydronium ions times minus 237.18 kilojoules for every 1 mole of hydronium ions. Okay? And then plus 1 mole of acetate ions and minus 369.31 kilojoules for every 1 mole of acetate. Okay? Now minus the reactants, and there is 1 mole of acetic acid, and it's minus 396.46 kilojoules for every 1 mole of acetic acid. And then minus 1 mole. I've got a letter for you. So
excellent.
Okay.
I was walking out of this office.
Come back in a few minutes.
Just leave this right here, so I can't leave.
Okay. Sorry about that. Minus 1 mole of, where was I? Oh, water.
No,
hydronium ions. Okay. Oh, wait a minute.
No,
Of water.
Yeah.
On the wrong side. Thank you. 1 mole of water and minus 237.18. One mole of water. That line best be there in your process. No shortcuts. You see, we've got it all there. I know this is a minus times a minus, and that's a minus times a minus. We'll deal with that later. But this, if you make a mistake and screw up the rest of the math, this is most of the problem. Just simply writing this out. You've already done what I was looking for. You have the ability to set it up properly. So that's what I'm going to be looking for. Don't take any shortcuts. I want to see something that looks like that on the page. And now we can go to our scratch paper and do our calculation. I can note that this and that cancels out, so it turns out to be an even simpler problem in this case. It's going to be minus 369.31 kilojoules minus a minus, which is plus 300, so it's 396.4 minus 369.3. So yeah, I can write that as so delta G is equal to, and I can go over on my scratch paper and go 396.46 over minus 369.31. That's a 5, that's a 1, that's a 7, and this is a 8, which is 27. Yes, you're absolutely right. Is plus 27.15 kilojoules per mole of the reaction. This was scratch paper over here. Okay, so as long as you have all this laid out, you can then put the answer. If you do it the other way around, you just put the answer and you don't have all that laid out, you'll get about the same amount of points that I would deduct for making a mathematical mistake, which is about 2 points. And so you get 2 out of 10 or 8 out of 10. Which one would you prefer?
10 out of 10.
Yeah, 10 out of 10. Don't make a mistake and you get it all. But if you just put this, I'll give you 2 points for having the right answer. And if you have the wrong answer, you'll get 1 point. Or 2 points, probably. Yeah, I'll feel guilty to give you 2. But you're not going to get there. Okay, yeah.
Why is the final answer kilojoules over mole if all the moles?
Okay, that's a good question. That's a very good question. I'm keeping this because this was per mole of this, and you're right, the moles did cancel, but I'm going to be, this is for the reaction itself. For every mole of this reaction, it's going to be 27.15 kilojoules. It's a scaling feature I'm sort of keeping for the next part of the problem. Okay, and I could lose it here. I don't have to have it because it's going to drop out in the next step anyway. And so I could either lose it here or lose it in the factor that I'm going to use to divide this by to find pK. Okay. So is everybody comfortable with number 3A? Okay, this was A. And now we go to 3B. Now B is going to take a little more scratch paper. This is the feature we want to call upon is reflective of our approach to this subject from the start. There being about 300 billion possible equations that we would have to use to solve a particular problem of the given set of conditions. There is no way any mortal human being could memorize all of that. So what we do is we know a handful of laws. We memorize that. You know those laws, and the whole thing we're supposed to be doing all semester is taking the laws and fashioning the appropriate expression for a given set of conditions from the laws. And that's the real feature you want to practice. So even though you may already know what the next equation is, always go through it real quickly in your head. So you're connected to ground. It's keeping your feet on the ground. We stand upon the laws. The laws are irrefutable. They are unimpeachable. So if you're standing on those, you're on good solid ground. So keeping our feet on the ground, the next part I'm going to start out with, I'll write the problem, part B. Maybe I should do it on this board. Part B. Find pK. Perhaps, can we cut this for a second? I have to take care of